Hello everybody, welcome to this live webinar. Before we start, again, please connect on Bcast. Thomas Lejeune will explain
thanks,
how to interact with us.
If you can, please use your smartphone and just scan the QR code or enter bcast.com/headlamp. Why should you connect to Bcast? In fact, you can interact with us, you can ask your question and we will answer them. But also you can participate to some activities that we create for you and that we will display during the presentation. So the first activity is already started. You can interact now with us. And the first question concerns your projects regarding ADB projects.
Thank you, Thomas. So I'm Cédric Bélanger, Product Marketing Manager at ANSYS OPTIS. Shohei Fujiwara is a product engineer, and he will speak today about the smart headlamp. First, I will start with a few words about OPTIS, ANSYS. So OPTIS is a world-leading company in virtual prototyping, recently affiliated with ANSYS. ANSYS is a market leader offering a platform with best-of-breed simulation across all major physics, structures, fluids, electromagnetics, semiconductor power, mission-critical embedded software, and optics. OPTIS is in charge of optics, and what we do is we simulate the performances of light, human vision, and material in interaction, ultimately allowing you to experience your product, like a headlamp, virtually before ever spending the time and money to build multiple physical prototypes. So today, smart headlamp. First, Shohei, what is a smart headlamp?
The smart headlamp is the adaptive driving beam, but at the same time, it has the sensors inside, LiDAR sensor, camera sensors.
Okay.
This is what we call smart headlamp.
Okay, and this is the trend.
Yeah.
Yeah.
It's coming trend.
Okay. So I think this is the introduction of your next slide.
Yep.
The technology trend.
Yep. So today's technology trend, it's the having more and more sensors for ADAS technologies and the future coming autonomous vehicle. And for the lighting, the ADB, adaptive driving beam, it's the technology trend like matrix beam or pixel lighting or some may call digital lighting. This is the technology trend, and the idea of a smart headlamp is having them together. Having LiDAR sensor, camera sensor inside headlamp. So that means the headlamp will be the all-in-one product. So this is what we call smart headlamp, and for the headlamp suppliers, that will be additional value. And the another advantage is simplify the wiring. Currently, headlamp and sensors are separated, so the wiring harness is going different places. But if everything is integrated inside headlamp, the connection is only one connection to the lamp. So the wiring will be simple somehow.
So yeah, the benefit of integrating sensors is first to simplify the wiring harness. That's for the OEM, the car maker.
Yes.
And for the supplier, it's to add value to the lamp.
Yes.
Okay. I think it's time to maybe have the feedback of your feedback from the poll you had in Bcast. So how many projects do you have for 2018 and 2019? Okay, so it's for 2019. Can you display it? Well, okay. So it's for this year it was 60. No, not a lot. Between 1 and 3 for 40% of you, okay? And between 1 and 3 and more than 3, between 1 and 3 for the coming year, for 2019.
Yeah, the number of projects is increasing for the
Yeah.
years that
Yeah.
is coming to be busy.
So that means everybody has the project next year.
Yeah, for next year, for next year.
Great.
So, okay, so we continue, and there is a new activity, a new question on Bcast.
Yeah, we
If
ask
you are not already connected, connect to Bcast to answer
Yeah.
the second question.
Yeah, the second question is what are the challenges you encounter by designing ADB? So you can type a word right now.
And we are speaking about the design, so we are going to start with
Yes.
the design
Yes.
of the smart headlamp.
Yes. Well, from now on, let me introduce what can be possible thanks to our solution. So first, I'm gonna demonstrate one of our product spills regarding the lighting design and sensor specification and sensor layout. And after that, I will switch to another product, VR experience, to explain the virtual lighting evaluation. So let's begin with spills. Here, I've got a car, and here is headlamp. And as you can see here, this is not the same as the conventional headlamp. Here I have the lighting module, forward lighting, and LiDAR sensor, and camera sensor here. And the lighting signature here. This is a daytime running lamp and turn indicator at the same time. Okay, so let's begin with lighting design. For example, this lens is made with this feature. This is the feature developed by OPTIS. The name of this feature, this module, is OPT, optical part design. And here you can see several icons to create the complex optical geometry. Let's see the interface. For example, this one is projection lens. So definition is your focal point, optical axis, and focal length, and some other geometric parameters. Then automatically the geometry is created. It's quite simple and fast. And the other example is this lighting signature. Let's hide car geometry and some other geometry. Okay. So as you can see here, this lighting signature was some may call light blade. It's made with a light inlet and a reflection on the back and output face here. Sorry. And as I showed for projection lens, the similar interface is available for every features. For example, this one in a light inlet. Several geometric parameters. Then the geometry, like this, is automatically created. And this back face and this front output face as well. And imagine that if you have to create this kind of small prisms, hundreds of prisms along the stylling manually, it takes hours or a day or even days. But thanks to Spell's OPD, it can be finished in minutes. So you can make several iterations using different parameters to investigate the performance, appearance. I said performance or appearance. Of course, you can evaluate these kind of things in spheres. For example, regulation. This is the beam pattern from this lighting signature. And this is a part of a classic optical simulation. So you can check intensity value and you can check the regulation. Regulation template is available, so you can check it immediately. If it is okay, you have green. If it is not okay, you have red here. In this example, everything is okay. And of course, you have to check the appearance, how it looks like with your design. So we have the physics-based rendering. This is one of our strong point. Yeah.
Before we continue, Shoei,
Yeah.
I just want, as we have a question dedicated to this part, I just want to close the question we
Yes.
had right before regarding the challenges. So the challenges for you, a lot of physical prototypes.
Yes, a lot of physical prototype, but we
Great.
also have regulation, test certification, time to market as well. Time.
So that's regulations. That's interesting because you have just demonstrated that we are able to check the regulation in virtual. So we're able
Of course, yeah.
it's numerical certification
Yes.
of the headlamp, the performance of the headlamp in virtual. So we are able to deal with these challenges. I wanted just to jump to the next question before Shoei showed the images, or while he's showing the images, the rendering of the light appearance, the light signature. So the next question is: are you satisfied of the lighting appearance of the result displayed by your actual software?
Okay.
So yeah, please.
So this is another rendering image in the dark condition, daytime running lamp or a position lamp. Or turn indicator. And depending on your needs, you can change the point of view, viewing direction, and run another simulation to check the appearance from different point of view. Okay. So this is the quick introduction about the lighting design and evaluation. So let's switch to the sensors. Okay. So before starting, okay, let's see the scene used in the simulation. This is something just we made up, having several vehicles and pedestrians. It's quite simple environment. This is simply made in CAD, so you can create whatever you want inside the CAD, and you can consider it in your simulation. Okay. So let's begin with LiDAR. As I told you here, I have a LiDAR module. And in the spheres, we have developed the function to simulate LiDAR. This is a LiDAR simulation module. And this is the interface of our LiDAR simulation tool. You can define the source here. You simply define the axis system and spectrum and intensity, beam intensity pattern. And for receiver, the axis system and some optical information like distortion and image dimension. And you can define the simulation. using a defined source, sensor, and a user-defined geometries around. So that means you can consider the bezel, for example, this one, and also the object in the scene, like pedestrians or other vehicles. Yeah. And I guess one of the use case is to try several different LiDAR module. For example, the different focal lengths of a receiver. So simply define the emitter, receiver, and simulation, and run the simulation. Then you can obtain the simulation result like this. It is a false color map showing the distance from LiDAR. So this one is a simulation result with a shorter focal length. And this one is simulation result with longer focal length. So you can check how much this LiDAR module can detect, how wide. So to test a different configuration, just define several different LiDAR simulation. Simply changing some parameter here, for example, the focal length. If you want to change the image dimension, you can modify here, or resolution. So you can test a lot of different configurations of your LiDAR module. Virtual. Okay. So next, let's see the camera. We have the camera sensor inside the space. The definition is quite similar to LiDAR receiver. This is the interface. So the position and direction, axis system of the camera, and optical information transmittance, distortion, and sensor dimension. So you can use this camera sensor in your simulation and considering the geometries around. So you can do the similar thing as like a simulation, for example, different field of view. Obviously, these two images are different. This one, right one, it's a narrower field of view, and this one, left one, is wider. But let's say if you want to see if you want to have wider images with this camera, but if you put the camera with wider field of view inside the headlamp, you have a lot of the object inside headlamp bezel. The most part of images are blocked by the bezel. So thanks to this simulation result, having a wider field of view camera, it's not a good idea, I think. So you can do this kind of test quite quickly. And another interesting point is the reflection on the outer lens of the headlamp. Here I have some reflection here, and here too. And sometimes, for some reasons, you may have a different option of outer lens shape. Outer lens shape is part of class A surface normalities coming from design studio. So design studio may have some different ideas of styling, and from engineering side, for some reason, the shape of outer lens may have to change. So for every possibility, you can check the effect of outer lens. For example, in this model, I have two different outer lens.
Maybe just before you continue, we can make a review of the question, the last question. Are you satisfied of the lighting appearance result displayed by your actual software? I think it's important because before you finish on Speos, it's important to notice that the people, they are not satisfied, and they need an improvement regarding the images.
Yeah,
And
80% of you say that it could be improved, and 20% think that that they are not satisfied actually.
Yeah, and it's something that is key in our software, is that the human vision module, you are very able to experience the light appearance of the light signature, the daytime running light, like in reality. So that's really important, and we have a really strong point here.
Yeah, this is the one of our strong point.
We will launch the next question and continue with the explanation. The next question is which technologies, which sensor technologies are you considering to integrate in the future?
Smart lighting.
Thank you. So the different outer lens, I have outer lens 1 and 2. This green one is outer lens 1, and this pink one is outer lens 2. I think it's easier from this point of view. So this pink one, outer lens 2, is more curved at the center. 1, 2. Okay. And I run the simulation using these two different outer lens. So let's see the difference. Sorry, not this one. Okay. So first, this result is made with outer lens 1. As you can see, a reflection here, here, and here. And next, this one is made with outer lens 2. Obviously, you cannot see the reflection at the bottom here. And the amount of reflection at the top is slightly different. So this kind of difference may happen due to the shape of outer lens, and you can detect it virtually without making physical prototype. So especially at the beginning of development, the styling is changing a lot. So for every option, you can check the possibility of issues. Okay. And the other interesting point could be the styling. For example, you may want to put this camera deeper, for example, or close to outer lens. Usually, from styling point of view, deeper is better.
You want to hide
the
element.
Exactly. But what happens if you do something like that? Put the camera deeper inside.
The field of view is...
Yeah, you can imagine that part of field of view will be blocked by this green bezel. And easily you can simulate how it will be. And this is the appearance. You can see the camera here, or for example, camera here,
Yeah,
deeper.
the difference.
Yeah.
It's quite clear.
Sorry. But at the same time, the view from camera
Yeah. Okay.
could be
The field of view is completely different. Yeah.
quite different.
Yeah.
So you can
Okay.
compare the
Okay.
results and check and define the
So here,
Best configuration.
the value of this is you are able to define the specification of the sensor and to define the layout.
yes.
Okay, and you are able to test the camera in lighting conditions, the horn light of the headlamp, but also in the lighting condition of the incoming vehicles. And you
yes.
test also the outer lens. You test the shape here, but you are able to test the material, different materials for
Of
the
course,
outer
of
lens.
course, yes.
Okay. Well,
So this one is the example with a lighting condition. So the headlight is on, so you can see some reflection of my headlamp on the outer lens.
okay.
Okay.
I think we will go on VR
Yes.
experience.
So let's see the
Experience.
VR experience. This is the solution for real-time lighting evaluation.
Impossible.
You can launch here if you
Yeah.
want to make a wrap up on the question.
So yeah, for the last question, which sensor technology are you considering to integrate in the future smart lighting? You are 42% to say that you would like the camera, and 35 LiDAR plus camera, so the combo, and LiDAR in third position for 21% of you.
So some of them are considering the LiDAR alone.
LiDAR, yeah, that's interesting.
Yeah, only 21%, but the first one is camera and the combo.
Mm.
Okay, thank you for your activities. I will launch the last one. So the last one is regarding this solution, so I'll let you present your
Okay, thank you.
first.
Okay, so here, as you can see, there is a road and my car and some other cars. So this scene can be created by user. And in this example, it's a simple, little bit twisty country road with some vehicles. And what you will see here, it's the pixel beam controlled by a user-defined control law. So you will see some mask on preceding vehicle, on coming vehicle. So let's see.
Yeah, we see the mask here.
Yeah.
So you don't glare the incoming vehicles, but
Yeah.
also the
And
follow
the
the
vehicle in
vehicles you
front.
follow. Okay.
So this is the typical behavior of pixel beam. And depending on the setting in your lighting control law, you can modify the size of mask.
And what are the straight lines?
The bars on the road is distance warning. Currently, this car is braking in order to turn right. So distance between this car and your car is getting shorter. Then you have distance warning, and currently this warning sign is indicated in negative way. The bar is dark. This is negative. But of course, the positive is possible. But in both ways, you need to check, for example, how much contrast you need to make it as obvious, as clear as possible. So testing, you can test several different contrast level. This one is quite low contrast. It's almost invisible. In dark gray and dark with higher contrast. And how many bars you want to have. This kind of manipulation, modification can be done by user-defined control law. So let's continue. And as you can see here, in this scene, we don't have center line. So this dot is indicating the virtual center line. And you can do similar thing, positive, negative. Or how much dots you want to have.
Okay, that's nice.
So this kind of evaluation test can be done in a virtual real-time environment.
So yeah, I think we'll finish with the last question, and I think it will be related to what you are going to announce, because yeah, the last question, would you be interested having a physics-based camera in a virtual driving simulation platform? Of course, a majority of you answer yes. It's quite obvious you need this kind of physics-based camera in a simulation, driving simulation like this.
Yes.
So today we don't have. Here we are just working on the lighting performances and on the control law.
Yes.
But for the future, the near future,
VRX,
VR Experience 2019, you will have
physics-based camera. Yeah, it is coming.
Okay. So that's good news.
Yeah, exactly.
That's good news for all the projects you have in the coming years. In 2019, they will be able to work on this technology.
Yes.
Okay, so just the wrap up. Yeah, the value of our VR experience is you work on the lighting performance, you work on the control law, and thanks to VR experience Headlamp, you assess the lighting performances and the control law in real time, in real conditions, whenever you want.
Yes.
You don't spend night on the track test, as you know.
Whenever, wherever.
Okay, so that's the benefits. Replace the costly and time-consuming night tests.
Yeah, exactly.
Okay, thank you. Maybe
Yeah, we do have one question already.
Okay.
So please, if you have one question, you can ask us on bcast.com. So the first question, I'll display it,
okay.
is I would like to ask the possibility to simulate radar.
Simulate radar.
Radar. Radar simulation. It is, for the moment, it is not available in both platforms, I think. But it is, of course, it is planned.
Okay.
Yeah. In the development plan.
Okay.
Yeah.
Well, the link we have with ANSYS, I think we will be able to simulate the radar very, very soon, no?
I think so.
Yeah. Okay. So it's coming for next year, for sure.
Yeah.
Okay. Another question, maybe?
We don't have any other question yet, but we can wait just a bit if some appear.
Okay. So, but we will. I think it's
It's time.
Yeah, it's time. So I will just we will
let the bcast open if you
let's
have
because
some
open. So
question.
if
We
you
can,
have any question,
yeah, we can answer after, or you can contact Shoei as well. With
Of
the
course.
email address.
yes, you can contact us if you have if you want more details, and stay tuned for the next webinars. Thank you very much for your attention. Have a good day or night.
Thank you very
Bye-bye.
much.
Thank you.